So find the period, domain, and range of each function. So we're going to get more into graphing trig functions in the next couple sections. This is just kind of to show you what periodic behavior is. Okay. So periodic behavior, you may have seen something like this before. What does this kind of look like?
Cosine curve.
What kind of curve? But
Negative x before.
yeah, but where do you see that kind of stuff? Where would you see this? Heartbeats, stock market. Okay. There's all kinds of real applications for this stuff. As a matter of fact, it's time for another story.
Yay.
So I'm never going to finish. So anyway, so this is a periodic function. The period of this function appears to be, so to find the period, you just go from where it looks the same to where it looks the same. So if you count over here, how long would you say the period of this function is? About 6. 1, 2, 3, 4, 5, and a little bit. So maybe for function A, the period is about 6. The domain appears to be all real numbers, right? All real like that. And then the range appears to go from, we could write it, I finally figured out they write it like this. Y, how do they do it? The range, they go like this, Y, and then they draw this little bar like that for some reason. And then they go Y is greater than or equal to negative 1.5, not that negative, sorry. Negative 1.5 is greater than equal to Y, and it's less than or equal to, it appears to be about 1 or something. Okay? For this function, this is either a cotangent or a cosecant or something like that. This has a period of 2 pi, because if you look from here to here, see how it repeats itself every 2 pi radians? So the period of this is probably 2 pi. And is the domain all real? No. Okay. So you would do something like, say, x bar, x is not equal to, and the way they do this is they go pi times n or something like that, where pi is an integer. So at every multiples of pi, you have an asymptote. Okay. So x is not equal to pi times n. We'll get more into this as we're graphing trig functions.
Wait, x cannot equal what?
Multiples of pi. See how there's an asymptote here at negative pi and negative 2 pi, at 0 then at pi. What? N is an integer. So if I plug in any integer in there like 1, that make 1 pi, or 2 pi, or negative 1, that'd be negative pi. Okay? And then y, you would write it, y, you do a little bar, they do this squiggly over here, and then they go y has got to be greater than, I think this is 1 over here, okay? So y, you would write y is greater than or equal to 1, or y is less than or equal to negative 1, like that, okay? And the only reason they have all these things here is to talk about how trig functions repeat themselves. They are periodic. And sine, cosine, and tangent, sine, cosine, and tangent, and cotangent, and secant, and cosecant, they all repeat themselves. Okay? So sine, its period is 2 pi, meaning it goes around, you have the exact same values every 2 pi radians, as does cosine. As does cosecant, which is the reciprocal of sine, which looks like this or like this. I'm not sure if that's cosecant or secant, but we'll talk about those later on. Okay? So one of these is this is either cosecant or secant. I don't remember which. Okay? Tangents and cotangent, they repeat themselves every pi radians. Okay? So for example, if you have a unit circle, I'm just going to draw some lines here. Please. Okay? So you'll find out that like the tangent of 30 degrees is the same as the tangent of 210 degrees. Okay? Because you're dealing with the same angle here. And so that if this were 30, then the tangent we already found out is root of 3 over 3. And the tangent of 210, which is 180 degrees or pi radians past 30 degrees, is also going to be root of 3 over 3. Because remember, x and y are both negative, and a negative divided by a negative gives you a positive. So it repeats itself. Okay? Likewise, the tangent of, say, 135, or the cotangent of 135, which would be 90 plus 45, that's going to be exactly the same. That should be a 45 there. That's a tangent of 270 plus 45, or 315 degrees. You see that? Okay, so tangent, cotangent repeat themselves every 180, or pi radians, and sine and cosine and secant and cosecant repeat themselves every 2 pi. So how do we use that to do math problems? You do that like this, cosine of 420. We already did ones like this, right? You can tell me how to do this. Right, because cosine is periodic, then the cosine of 420 can be rewritten as the cosine of 360 plus 60, right? And since I know that it repeats itself every 360, this is equal to the cosine of 60. And since I know my unit circle, who knows what that is? 1/2. Very good, Austin. It's either root of 3 over 2 or 1/2. And no, the cosine of 60, that's cosine of 60. The sine of 60 is root of 3 over 2.
Let me look at my chart.
So cosine of 60 is 1/2.
Yeah.
Okay? So that's correct. Sine of 9 pi over 4. Okay? So if I were doing that one, 9 pi over 4, that's the same as 8 pi over 4, which is twice around the circle, plus pi over 4, right? Which is equal to the sine of pi over 4, which is, math cheer, root of 2, right? Root of 2 over 2. Okay? Now the tangent of 21, since tangent repeats itself every pi, so that's going to be equal to, that you could write that as, say, the tangent of 20 pi plus pi, which, because tangent repeats itself every pi radians, it would be the same as the tangent of pi. Okay? And the tangent of pi is -1 over, no, it's -1, 0 over -1, which is 0. Okay? So that's how you do those. I already kind of told you this yesterday, right? That sine and cosecant are positive here. Everything else is negative. Okay? This means that everything, sine, cosine, tangent, cosecant, cotangent, they're all positive here. This means that tangent and cotangent are positive. Everything else is negative. Here, cosine and secant are positive. Everything else is negative. Okay, greater than 0 means positive. Yes? Good? Okay. So then, how do you do problems like this? Once you have all that info, I'll show you how you do problems like that. First, you go like this, and then reciprocal identities. Oh! So, let me take a picture. Partial, name the quadrant, and I'm going to take a what. So, all this means is, use that little chart above that I gave you. You want to figure out which quadrant you're in, okay? So it says sine is negative and cosine is positive, okay? Where is, in other words, where is y negative and x positive? Quadrant 4, right? Or they write it IV, right? Like that. Okay? Where is secant negative, which is the same as cosine being negative, and sine positive? Which quadrant? I'm up here, right? Quadrant 2, up here. Secant is negative because x is negative, and secant is the reciprocal of cosine. Okay? Here, cosine is negative, and tangent is positive. So, it's got to be down here, right? Because cosine is less than 0, tangent is greater than 0, and since cosine and sine are both negative, that makes tangent positive. Okay? And so then you're in quadrant. Any question on that? That easy? That's pretty easy, right? Okay, moving on. Reciprocal identities. These things I already kind of told you too. These are called the reciprocal of identities. Do you think Sam can tell me what the reciprocal of sine is? Cause he can't. Cause he can't. But he could. That's pretty good, huh? But you could. So cause he could, that would make sense. So I was hoping you couldn't help. So sine is 1 over cosecant. Cosine is 1 over secant. Tangent is 1 over cotangent. Cosecant is 1 over sine. So these are opposites of each other, right? And so on and so forth. These are called the quotient identities. You should know these. Tangent is sine over cosine, and cotangent is cosine over sine. And we use those a lot when we get to the identities section, and we'll have some problems based on these. And then we have these things called the Pythagorean identities. Sine squared plus cosine squared equals 1. That's just coming over out of the unit circle, right? Because if the radius is 1, then x squared plus y squared equals 1. This is a very important thing to know. These ones also come out of that unit circle. They're not as evident though, but you are going to be expected to know these, especially in the next chapter. So 1 plus tan squared equals secant squared, and 1 plus cotangent squared equals cosine squared. So how do you do problems like this? I'll show you how you do problems like this. So if you have something like this, find the exact value of the remaining trig functions. So I would always draw a picture for this, for these types of problems. When you see them, I'm not going to draw a whole circle. I get just straighter when I'm looking this way. Okay? So what you do, the way you do these problems is you say, okay, which quadrant am I in? Cosine is negative. Oh, it says in quadrant 3, so I just draw a picture of it, right? So I draw a picture in quadrant 3, okay? Over here, that's not what I want. I want my arrow tool, okay? So I draw a picture over here in quadrant 3 of an angle that looks something like that, okay? And then, I don't want arrows on the end of my lines. And then I say that cosine is negative 4/5. So you call this negative 4. And you always make the hypotenuse positive. Okay? And then you use the Pythagorean theorem to find this side. What's that side going to be? That's negative 3. You have to pay attention to the sign, right? Because you would get 3, but you have to realize that y is negative down here and x is positive. So to find the remaining trig functions, all you have to do is, you should write sine of theta is negative 3 over 5. Okay? And cosine theta we got already. Okay? Tangent of theta is what? What's tangent of theta? 3/4. 3/4, right? And cotangent therefore is 4/3. Okay? And then we need cosecant, which is the reciprocal of this, which is just negative 5/3. And secant theta is the reciprocal of cosine, which is negative 5/4. Is that hard?
Yeah.
That's hard?
Too hard.
Too hard. Okay. The next one, what you want to do is, with this next one, where was I? Here? Here is where I was. With the next one, it's a little more confusing in that they don't give you the specific quadrant, so you have to kind of figure out which quadrant you're in. Okay? And the way you do that is by realizing that sine is positive and tangent is negative. So where is sine positive and tangent negative? Second quadrant. So you're up here in the second quadrant. Alright, so you draw whoops, now I put arrows on my lines again. I want arrows on my, okay? So you're up here in the second quadrant. No more arrows. And you draw, tangent would be opposite. Oh, sorry. Yeah, 2 and 3, right? That's a 3. Oh, I got arrows. I hate when that happens. Okay, I don't want arrows on my lines. That's bad. So this is a 2, and this is a 3. And then you do the Pythagorean theorem, 2 squared plus b squared equals 3 squared. And you get 4 plus b squared equals 9. So b equals the square root of 5, right? Okay? So this is root of 5. Is it negative or positive?
Negative.
Negative, because x is negative in the second quadrant. Okay? And then you do sine is 2/3, cosine is negative root of 5/3, cosecant is 3/2, secant is 3/negative root of 5, and so on. Is that hard? You got that? That's hard, Lana? All right, moving on. I'm not going to do that whole thing. But moving on, these are called the even and odd properties. Okay? So what this says is that the sine of a negative angle is the same as the negative sine of the positive angle. For instance, if I have sine of negative 90, that's equal to negative sine of positive 90, which is negative 1. Good? Do you understand that? That's what these even and odd properties say. Okay? So cosine is an even function because the cosine negative is the same as the cosine of positive. So the cosine of negative pi/4 is going to be exactly the same as the cosine of pi/4. And you should know that is the math here, which is root of 2/2. Okay, positive. Okay? Cosine of pi/4. Tangent is odd. Okay, so sine and tangent and cotangent and cosecant are all negative. The only ones that are odd. Okay, these are odd. These are odd. These are even. Good. And so the secant of a negative angle is the same as the secant of that same positive angle. So the tangent of negative pi/4 using this one is the same as negative tangent of positive pi/4. And you should know that the tangent of pi/4 is 1. And so this ends up being negative 1. See, I'm not even looking at my unit circle because I have memorized. And that's
Yeah, but how many times have you
a
done
lot for years and years and years. But it's really nice to have that in your head so you don't have to like figure it out every single time. Yes.
315 degrees, what are the X and Y coordinates?
315 degrees, what are the X and Y coordinates? Don't tell me negative, positive root of 2 over 2, negative root of 2 over 2. Right? There you go. Okay. So the tangent of 40. So with these, you're using some of these properties. Tangent of 40, you rewrite it. What's sine of 40 minus over cosine of 40 equal to? Using this identity, this identity, the reciprocal identity back here. Sorry. Going back, where do we go back to?
Recall.
Oh, it's not there. Back. Let's just look at our original table, okay? So, going back to here, you see that sine over cosine, if those are both the same angles, they're equal to the tangent of that angle. So the way I do this one down here, okay, is I'm going to rewrite this as the tangent of 40 minus the tangent of 40. What is the tangent of 40 minus the tangent of 40? 0, okay? And that's the answer. You don't have to touch a calculator. Come on, I'll put your phone away. Thanks.
Wait, why is it?
All right.
Why is it subtracting?
Because this is equal to the tangent of 40 because of that reciprocal identity. Okay? Right? Sine over cosine is equal to tangent. That's it. Okay? Now I'm going to use some properties like this to try to simplify this as well. Tangent repeats itself every how much? Pi. So this is the same as the tangent of what? 180 degrees is pi. So that's the same as tangent of what? No, not 180 plus 20. So that's exactly the same as the tangent of 20 minus 1 minus the cotangent. Oh, that's a times. Times the cotangent of 20. And so I know that this is tangent of 20. How can I rewrite the cotangent of 20 using a reciprocal identity? 1 over the tangent of 20. And what happens to these two things? They cancel. And I get that that's equal to 1. Okay? So when we come to a test, we have some simple identities like that. Because tangent is periodic every 180 degrees, right? So that's equal to tangent of 180 plus 20. Right? Because it repeats itself every 180 degrees. So tangent of 20 is going to be the same as tangent of 200. Yes?
Is all that homework really our homework? That's all I